2 years ago, I really wanted to work on Unity because it's a great simulation software package. It's a great way to simulate things. Now, many of you know Unity as it's the system that people use for game development. It's one of the major game development platforms. So there's Unity, there's Unreal, and there's a couple of other ones out there. Obviously, a lot of people use their own custom work out there in platforms, but Unity's a big one. The reason being that it's fairly inexpensive. It's $35 a month if you're on a subscription. We're actually using it for free today. They have a free version, and you can do all the AI stuff, it seems, for free. So, I mean, you can't beat that. And they have it easily compiles to iOS, Android, Linux, WebGL, all kinds of things. So it is really cool. I'm really excited about that. So Unity, if you've never worked with it before, I would highly recommend. This is a good place to start. In fact, it's this low barrier of entry which makes it so popular for people. Okay, so definitely check that out. You can go to Unity. Here it is, unity.com, and you can check out that information. Now, they use it for all kinds of things. So games, film, animation, architecture, engineering, construction, automotive stuff, obviously. But let's look at this. Now, this is the cool stuff, I think. So this is the machine learning stuff, and it's really AI stuff. This is all trained on deep reinforcement learning. And if you're not familiar with it, we're going to talk a little bit about what that is and how that relates to stuff that we've done in Lancaster AI. But let me quick tell you a little bit about what they have here. They have this simulation, and as you can see, you have these actors, if you will. They're called agents operating in an environment and doing things in an environment. And there's these games going on. We're going to talk about why games are so good for this. But this is it's called ML Agents. It's in beta. So we're going to talk about the challenges of what that means. But they have some really awesome things here, like stabilizing satellites, pancake bots, looking at wave stuff. They have reinforcement learning, which is like traditional rewards function kind of things. So, and they have a lot of stuff on their blog and everything about that. So this is a great place to just find out about what Unity machine learning is. Just a general introduction. Okay. Now, let's talk about the real challenges here. So, first of all, I'm dealing with Linux. So some of you who are on Windows or Mac are going to have a little bit different setup, and that's cool. However, most of the AI stuff out there is really built for Linux right now, and there's a lot of reasons for that. Still, for the time being, you have a lot of CUDA for your training and optimization, so that cuts out most of the Mac stuff, unless you're using cloud-based work like AWS or Google or some TPUs or in the cloud or something like that. You can use any platform you wish, but if you want to do things locally, generally you have to have Linux or Windows. And I hate to say it, but Linux is still a better dev environment, despite all the progress that Microsoft has made. So what we have here is the setting up Unity with VS Code on Ubuntu. Now, I'm going to use Ubuntu. It's probably the standard Linux flavor right now, though there's plenty of other great versions of Linux. I'm using 1910. This is for 1804. That's okay. Everything still worked. You have to use a special setup, so I'm going to include this link in after we follow up here. This is a great guide, and this gentleman took a lot of time. And you really kind of have to go through this. You install the Unity editor. So we install this thing called the Unity Hub, which is like a container that will hold all of your stuff. I'm going to show you that. You install Visual Studio Code. If you don't have it already, you tell Unity to use Visual Studio Code. You have to install .NET. And something that nobody tells you on Unity, but it's something you really need, is you need to install Monocomplete. Because you will get all kinds of autocomplete errors in VS Code if you don't, which makes it really hard to dev on. So this is all the setup, okay? And after you do all this, almost everything works great for just working straight with Unity, okay? Now, here's the ML Agents platform that's in beta. This is where the AI gets attached to Unity, okay? And so what we have here is We have the ML agents. Now, this is beta software, so every month they're updating this. And every month they have semi-breaking changes. So you got to read the docs every month. So a lot of you may be like, oh, I don't want to have to deal with that. But it's okay. Like, the general ideas don't change. It's just sometimes the syntax changes, or maybe how you approach your problem might change. So, for instance, this is currently on version 0.15.1 as of today, which is March 31st. I'm using 0.14.1, which was last month's, and that's what I'm using right now. I will point out some things as I go through to show how some things might have changed, like some renaming or, et cetera, et cetera. So I haven't updated to 0.15.1 yet, but I will. Now, there's some cool things about this. So this allows you to control Unity using a lot of Python stuff. And Unity is what we call a C# environment. So that's the main programming language that a lot of Microsoft stuff is built in. And, it's a very standard language. A lot of people use it. But most AI stuff is in Python. And, there's some in Swift and C++ and stuff, but it's mostly Python right now. And you get a bunch of sample environments with this. If you know anything about algorithms, these are the actual algorithms that they build in for you. And they talk about, all these other things about how to use the system. I'm going to show you what they are rather than just tell you. Okay? But some of the things you got to do is they have a great documentation. ML Agents is actually fairly impressive with their documentation. So this is migrating. So when I'm migrating from 0.14 to 1.5, it tells me all the things that have changed and what I need to do. So the documentation is pretty good. And going through their install procedure is pretty straightforward. Like, it's not difficult. So if you have any challenges, good luck with that. You can post them on the Lancaster AI forum. You know where we are on Slack for most of you. So it's on Lancaster Tech. And if you're not on Lancaster Tech, you can email me at info@lancasterai.com and I'll get you set up with whatever you need to there. Okay? So let's keep going here. Let me check my... All right, awesome. Cool. So, what are we talking about next here? Okay, so the setup on Linux. Okay. So the question is, how do we handle artificial intelligence in games and simulations? Okay, so how do we do it? So right now, Unity, as I said before, I absolutely love this platform because there's a low barrier of entry and they have a ton of good educational stuff. And right now, it's free. Because of all the stuff going on with COVID, you can go in here and get all kinds of great free things. It's awesome. It really is. So right now we have, this is the one I would recommend. I'm still going through it, but it's been awesome. It's called Artificial Intelligence for Beginners. And you can, it'll take you through a couple of things. So it's a 15-hour course, okay? If you watch it at 0 speed, and you do some of the exercises and stuff. I always up my videos to at least 1.5 speed to go through more quickly. But it will take a little bit of time, so you do have to dedicate a couple of days to it, but it's worth it because a lot of these ideas will transfer to other things that you work on in AI. Okay, so for instance, the mathematics of AI and the physics of AI, which guess what it talks about? Vectors, magnitude of vectors, positioning. And these are all things that we've spoken about in Lancaster AI when we talk about vector mathematics, dot notation, all those kind of things. Well, now we can transfer that to this game development, and it's really great. The first ways that people often set up AI stuff is they'll go through and they'll handle things like waypoints, right? They'll do nav meshes, which are, they'll set up these environments where the AI agents can walk. Hold on, I guess you guys can't see that. How about I move this down? So you can set up environments where the AI agents can walk around and everything. And this is where all the places that they can go. Waypoints are particular positions that you have around a environment. So you can tell your AI agent to go here, go here, go here, go here, go here. Those kind of things. And often the AI stuff, a lot of it was using things called finite state machines. And finite state machines explicitly state what to do in an environment. So they say if the character is it within this space, this distance from you, then move into this. So if you're doing a first-person shooter, okay, and you have a guard who's on patrol, you would explicitly have a patrol method or class. You would have a searching, a shooting, and chasing player. Like you would have those 4 different kind of states that your person can be in, and you would directly control all the different things that would tell you, okay, you have to, if these criteria are met, then you're doing this. But it's very explicit. You have to say everything that you would want to do, okay? And that was AI for a long time, and it's still used a lot, finite state machines. And then we got into this thing called GOAP, which is goal-driven behavior. But GOAP stands for goal-oriented action planning. That's it. And this came out, it was designed by a gentleman back in 2004 from MIT. And this is his work here, okay? And GOAP was first used in a game called Fear, which was highly rated. And it's been used in a ton of different places, and it's really transformed a lot of what happens in the industry. And GOAP is this idea of using the world, different things that happen in the world, to define explicitly what your character does. So it's not tied to a specific chain of actions, okay? And what that means is, I'm going to interpret it for a lot of people. So, for instance, if we go to this white paper here that he wrote, symbolic representation of the game world state towards real-time planning. We go into this MIT paper. There's actually a part of it, and you should read the white papers, by the way, is symbolic representation of game world state. So essentially what he's talking about here is they set up the world under this. He set up, let's see here. We represent the state of the world with a data structure that can consist of a fixed sized array of symbols implemented as key value pairs. Okay? So essentially what he's doing here, and I'm going to hop up here real quick, and I'll try to draw as big as I can, is, right, you have an object, right? We all know these as JSON objects. You have a person who then has a different, like head, different properties. And so this is the key, right? We know these are the key. And then everything after this whole section, all this information is what's called a value. And you can nest it, right? So like if you had a person with a key, then you had a head, which is a subkey of person. Maybe the head has a subkey of eyes and nose. And maybe, this is, a shape or a color or something. So you have these key value pairs, and you have all this nested information going, all this nested information going here, 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 here. And so one of the key things in computer informatics is trying to locate and modify information in these huge nested things. So, an example that other people might understand, right? So in the game world, for game devs, they're thinking of the world as a symbolic representation of the world, like that the 3D environment and simulation that they're working on. Whereas front-end devs, they look at the same thing. So this is what React is. Okay, so React, if you look at this is the original here. This is the React DOM before change. So think of this just as, a table. There's 1, 2, 1, 3, 1, 1, 2, 3, 1, 2, 3, 4, right? And so the difference between these is that we added this extra piece of information here. So here, this is what we call an add. We added some information. Well, what React does is it finds any of these changes and then reworks the virtual DOM to represent those changes. So if you're in the front-end web dev environment, you see this problem as a way of quickly navigating these symbolic representations and making updates so that the users on the end of websites don't notice that information is constantly changing. Okay? So it's the same kind of idea. Now, if you're a coder, and what you do is explicitly coding, like maybe low-level stuff, you know this exact problem as something of declarative versus imperative programming, right? So imperative programming is you specifically tell the computer how to get from point A to point B. So here we have an array, and you tell it, okay, cycle through the array, do this particular thing. If it equals this, then you push this, and then you do that, and you get this, and boom, you're here. Whereas declarative is more known as you just have you give it a particular method to handle something, and you let the system figure out the best way to get to that final answer. Okay? So this is all related to the same issue of GOAP, which is goal-oriented action planning, which is you have these things that go on in the world, and you don't tell the system explicitly what to do. You let it decide what to do, but you give it a goal to accomplish, right? So all these things are saying the same thing, just in different ways. Okay? Now, if you have any questions about that, I'm happy to talk about it later. But it's just good to know that we're all dealing, essentially, devs in all these different environments with the same problems. We're just talking about them differently, using different dialects. Anyway, so that's how AI is handled. Okay? GOAP. Goal Action Oriented Planning. Now, deep reinforcement learning. So if you've been in Lancaster AI before, you know that we went through a 10-week course using deep learning in the game of Go, which used a meta network to rebuild the Go champion that defeated the World Go champion at the time. And they used deep reinforcement learning as part of that. Okay? And here, this is another one, deep reinforcement learning in action. Manning Publications talked about. Essentially, deep reinforcement learning is this idea that you have a reward function. So you reward someone for good behavior, like B.F. Skinner, in the salivating dogs. Many of you know that story in psychology, where he would train the dogs to every time that right before he would feed them, he'd ring a bell, so they know it would be eating time. And then, soon he would just ring the bell without even offering them any food, and the dogs would start to salivate. It's a conditioned response, right? Based upon a reward of some kind. And that's kind of what deep reinforcement learning is. It's you get a reward function that rewards specific kinds of behavior. And so it's pretty neat how that all works together. In deep reinforcement learning, we have this idea of search methods. So many of you know A** search method if you're in the gaming world, to find the shortest distance to a particular place. I won't go through that right now, but that's something that a computer will work on. Deep Q networks, Markov decisions. These are some of the things that are covered in deep reinforcement learning. I'm not going to go over it today. I would highly recommend going through Manning Publications, though. They've never failed me. Like, all their topics have been awesome. You get topics as they're being written. I got a book called Grokking Deep Learning that I started on chapter 3, and by the time they published it, I had already helped contribute through the feedback mechanism to help improve the book in many sections. And it's very collaborative. It's awesome, and they run sales all the time. And if you're with me in Lancaster AI, I always recommend these guys, and they do great work. So that's a little bit about deep reinforcement learning. The challenge is, the key is, you have to pick up the exact reward to optimize the system. Okay? You have to pick the best reward. Because sometimes what you think might be a good reward isn't actually a good reward. Okay? So where do you see deep reinforcement learning have the best response right now? Well, things like, being StarCraft champions, or getting super high scores on games like River Raid. Remember the old Atari games? Well, that kind of stuff is actually this. This is deep reinforcement learning through the OpenAI Gym. And the reason deep reinforcement learning works so well here is because you have a tightly controlled environment, tightly controlled, all the parameters of the environment, whether it be physics or the environment itself, is tightly controlled, and you have a very specific task that you can give it to do. One task that it can train on over and over and over again, tens of thousands, millions of times, whatever it is. And so you see that all these things make this system very good. It can learn all of the things without you having to put in code for it. So, for instance, you don't have to necessarily teach this thing how to learn to walk. What you say is you reward it for the amount of time that it spends on its axis walking. You say, if you're walking and you're moving in a direction, you get a reward. And guess what? You just let it go for thousands and thousands of times, and eventually you'll figure out, oh, I got to turn over, and I got to move my legs like this. Likewise, in some of these games here, the system, you don't have to program in, hey, I got to dodge this or I have to do that. You reward the system for getting a higher score. And what that system will generally know is, oh, I got to learn to dodge enemies, and I have to learn to fire. I have to learn specific kinds of strategies. It'll teach itself those things, okay? Because because it gets rewarded for good behavior. And so that's why it works really, really well here. Okay? So, let's take a look at, well, that sounds great and all, but let's take a look at it in action. So this is OpenAI. This is just a random video from Montreal. You've seen all these kinds of videos by DeepMind using these AI stuff, but I'm just going to use this one as an example. This is trying to teach an AI agent how to walk. And every time it stops, that's the system failing. So it gets punished for falling over. Okay, so now it's starting to get better. It's starting to realize that you have to use your arms for the balance, right? That's what it's starting to understand and figure that thing out. See, it took a bad step there. Okay, and as we fast forward and go through this, I won't subject you to the whole thing, but essentially what you get by the end here is you get an agent that can run off the screen, and look at that. It goes pretty well. Look at that. Dead sprint. Ah, we're going. I mean, but it doesn't look like a human really, right? I mean, it does work, but it's not necessarily the best simulation. Like if I wanted to create a robot that wanted to act like a human, this would look really strange. It would look really strange on a robot. And so you have to be very careful what you choose as the reward. So maybe a way to make this better would be to reward it for mimicking a human in some ways, and other things like that. So modifying your reward. So again, the rewards don't always work, but picking the right reward is the most important piece of here. Okay. So let's take a look at what we got next here. So what do we got next? Okay. So let's take a look at Unity. So what I want to do here is we are going to, I'm going to pop up the Unity hub. All right, so this is how you do it in Linux. All right, so this is my setup. I obviously have a couple of setups. I've been working on a couple of different things. So we're going to use this one here. Just going to open that up. Take a sec. Okay, so that's one of the ones we're going to get to. So here's Unity. I'm going to give you a quick setup of Unity here. Okay, so Unity is, if you're used to Photoshop or Cinema 4D, if you're any of those media things, it's not too dissimilar. Basically, here's your panel of all your assets and things that you have, which is like your file browser. This is like your layers. Everything that's going on in your system here. And this is your inspector where you have like a lot of your values being kept. Okay, so right here. So this is actually we have a light in here. We have our main camera. and we have some settings in here, which we're not going to worry about right now. But this right here represents what we call a prefab. Okay, so if you ever done any work in Flash or a similar kind of software, this is like a symbol, right? So this is like or if you're a programmer, this is like a class. Okay, prefab is kind of like a class. Think of it that way. And this particular one is the 3D ball class, if you will. And so if we look at it, we see we have an individual one, right? And you know, we can rotate around and we can do all kinds of things on this. We can look at it from the sides, above, etc., and rotate around. All these things here to look at our little person. And we have different items here, and we have a ball. And this here, the thing that usually acts, is called an agent. And an agent has these things, parameters, and then some scripts. So what that means is that we have a ball 3D agent, right? And so this script here is this script, the ball 3D agent script. And so what we do is, these are all the components are, you can think of them as methods almost that control the object properties of your class, okay, if you're a coder. But what this means is that you add a collider on there, which is like it handles collisions with other things in the simulation, in your scene, right? So this script here has all this information where you have an agent, you initialize the agent, it tells you all these different methods that it attaches to this to control behavior. So it controls like interactive behavior, if you will. Okay? So I'm not going to go into that too much. I'm going to show you more in one of the next versions of this. But for now, I just want you to kind of see how this works. Okay? So this particular one is, it has this particular agent trying to bounce the ball on the top of its head. So if we have this here, the system looks pretty good, right? It's balancing, it learned pretty good. So this is one that's running inference, and it works pretty well for the most part. So this is just a sample, right? Doesn't need to train or anything. Okay, well, that's a great one. So let's look at one of the other examples here, just so you can get an idea of what we have. So this is a competitive agent one. So here's our scene, right? Now let's look at this one. This one's going to be a little bit more fun to play with, okay? So let me... Okay, so what's going on here? All right, so over here we have the game scene, right? So this is an individual scene where we have the two players working together, and the goal is obviously, you know, scoring on your opponent. And they let the individual players figure out how to behave and how to work together, which is kind of cool. So they trained them that way. And so you can train co-op competitive play together using simple, deep reinforcement learning mechanisms, which is awesome. But check this out. What the heck's going on over here? Now this is pretty sweet. So what you actually have here is, in the debug mode, you essentially have these things called raycasts, okay, which come out of the agents. So a raycast can be defined as the system going out and searching its environment for specific things. So this particular one is looking for tags, if I remember correctly. So so I can feel to I gotta find the agent real quick. Well, I'll show you on the penguin one what that is. So, but what you have here is they're looking generally for the ball, the walls, and the other agents, and the goal, right? So you can kind of see that, like they're always determining where they are on the grid map. And what this means is, though, is that we can train these concurrently. So this is one training simulation running at the same time. You can run bunches of them at the same time. So here we got 8 of them running concurrently, and they're running on the CPU. All right. So because a lot of their stuff is set to optimize on the CPU, which is fine, not a big deal in this particular instance. But it is pretty neat how you work in the 3D environment that way. Okay, and that is an example there. Awesome. So that's a little bit about how you might see this operate. Now, what I want to do is I want to take you through how do you actually build something and train it and make it look good, right? Okay. So let's take a look at something cool here. So I don't take credit for this. I take credit for very little that happens because usually it's on the shoulders of other people. Okay, so this is the Penguin tutorial. And this is a really good one. They updated it recently here. The gentleman who put this together updated it here for 0.14, which was good as of a month ago. Now it needs to be updated again, right? But he went through and you have free resources on here. So you don't even need to have a Unity Learning subscription or anything like that. You can go right in here and get all this stuff. It's awesome. Another thing I want to just quick mention is that almost all the things that you handle in Unity are imported assets from the 3D world. So if you're used to 3D work, these are usually FBX imports, and they are usually from like Maya. I mean, I think you can do FBX from Cinema 4D now, and a lot 3ds Max and some other ones. But you know, they have the materials in and everything like that, and so you import those and use them. But this gentleman went through and created this whole tutorial. So I'm going to walk you through kind of how it works, just in case you have any challenges. So let's take a look here. So we have our sample scene. All right, and again, we have 8 instances, I believe. I could have done more, but 8 instances of the prefab, okay, of the training simulation. So what does one of these things have? All right, so let's look at our penguin area. That's this one here. Let's look at our prefab. We have our penguin area. Okay, so our penguin area has this script attached to it, okay? And we're going to take a look at this. One of the things that it has is a prefab of a fish. All right, so let's take a look at what we're actually building. Let's do that first, just so you understand. This is what we're actually building. So we're building this little guy who's going to come out, find fish out here, bring it back to the baby, regurgitate it to the baby, and then go out and find more fish. And its goal is to find as many fish as possible before it starves to death, or the baby starves to death. And we use this timer here to calculate the current reward function, or the current hunger value, if you will, of the fish. And normally, if you had to program the AI into this, you might have to create all kinds of, you know, if-thens, calculate distances, and do all these other things, which you do somewhat, but we'll walk through this. But most of this is just simple goal-oriented work, okay? All right, so that's what we're building. So one of the first things that you have here is you have your fish. Okay, so let's take a look at the fish. Very simple. Has a little capsule rigid body around it. These things called rigid bodies. Everything that is in this 3D environment has to have some kind of wrapper around it so that it knows when it runs into something else, you know, do something. Okay, it has its own script. Let's look at that script real quick. All right, so let's look at our fish. This fish is a really simple one. So it just has this public float of fish speed. So the way that Unity works is that you make these public declarations here, and then if you go back into your fish, and we look at the script for our fish, where's our fish script? Where's our fish? There he is. See, we have a speed, fish speed, right? Well, that's this thing here. That's literally how it works. So if you need to interact with pieces of the 3D world, this will be things like, we're going to look at, this is how you get game objects and reference objects that are happening in the game and other things like that. You're going to do a public stuff here. And then these are private variables that you use. And I'm not going to go through it too much, but you have a couple of functions that are going through here. Hey, we got to tell it how to swim. And it goes through pixel random position. It rotates towards the target, calculates the time to get there, and then moves towards there. And make sure that it doesn't move past the target. In Unity, okay, you have these things called vectors. And these vector 3s are your position in the 3D world. So if you're in the AI world, this is like your vector origin point, right? And we work on things like transforming positions, magnitudes. So we actually manipulate the vectors directly in Unity's 3D environment versus letting the GPUs do it and kind of when we're processing some of our neural networks. Anyway, so, but that's our fish. Pretty straightforward. Not much going on, right? So, I love this part here. Regurgitated fish? Like somebody designed this. It was like, what's a regurgitated fish look like? Here's a blob, you know? So, I don't know. But that's a regurgitated fish. So it just shows up when it's supposed to. We'll find it. Regurgitated fish is referred to in some of other stuff. So let's look at our penguin area. So this is the area. This is the environment. Okay? And so we have a penguin agent, which we pass in, which is our penguin here, right? Penguin baby is the prefab of the baby penguin, right? So if we look in here, here's our baby penguin, okay? And then we have our penguin, which we drop in there. We have this thing called the cumulative reward, which is just, it's tied in via a script to let us know what's going on there. And I won't go into that. You can check out the stuff for that. They have some rocks in here, rock colliders, so that when the fish runs into it and says, oh, this is a real object, I should do physics calculations, water, etc. Okay, so let's go back into the penguin area. So the penguin has these different items. So if we go into the penguin area script, well, guess what? You would expect to have these public items: penguin agent, a game object, the text mesh, and a fish, right? And these, penguin agent, penguin baby, so this is a game object. This is our agent, the agent inside the area. See how that tooltip appears? It says the agent inside the area for penguin agent. That's this. This is our penguin agent. Okay, and that penguin agent we define over here. This is the actual agent which we'll come into. So that's where we define him. So anyway, could be a her too. But anyways, let's go through here and look at the area and the environment. So all we do is we have a reset area. So whenever we're done training, we set everything back to 0. So we remove all the fish, we place the penguin, we place the baby, and we spawn all the new fish. And then we tell it, how do you remove a fish? So when we have to remove a fish, if it just says we pass it a fish object, and that fish is removed from the environment. This is a function we'll pass later to our penguin agent. So when our penguin agent, let's see, remove, what's the name of the function? Remove specific fish. So we want to look for remove specific fish. So when it eats the fish, we call this remove specific fish. And it comes over here and says, we pass it a fish, and it says, fine, remove this and destroy that object. Then we calculate, oh, how many fish are remaining? And then this is choosing random positions. So this is how we, when we spawn our fish or our agents, it picks a random spot on the environment. Okay, and so it picks, Unity engine picks a random range with minimum radius, max radius. These are all things that are very explained in the tutorial, but I'm trying to go through them fairly quickly just so we can get to kind of the other setups. And this is here removing all the fish. So if we want to remove all the fish, then we call this function. And guess what it does? If it goes through, sees if there's anything on the fish list, iterates through everything, and destroys every single item on the list. This is standard coding stuff, right? Going through a list, wiping everything out, or doing a lambda function on a list. This is how we do it in C# using Unity. And then we create a new list, right? Which is a list is a very specific thing in Unity, which is highly optimized array, essentially. And there's some other things to it. I'll let you look up the C# documentation on it with Unity, but that's because it's used very often. The placing of the penguin, placing the baby. These are all methods to place things in the environment, spawning fish. And then when we start, we just reset the area. And this update function is usually called every frame. So every frame, we go through, we find the cumulative reward, or we find the, we get the cumulative reward from the Penguin agent, right, whatever the current reward is, and then we convert it to a string with this many positions on it, and then we turn that into the text here. So that's what we're updating in the area all the time. So these are all the environment pieces that we can manipulate. We can manipulate the state on. Okay, so we can remove fish, we can spawn fish, place items, etc., etc. So that's the big area. Okay, but let's get into where the heart of this is, which is the agent. Okay, the agent's what's going to get the rewards. And so we have a couple of public things that we have here. We have move speed, turn speed, the heart prefab, regurgitated fish prefab, right? So if we go into our agent here, okay, let's go into our penguin. Right, here's our guy. He's got a move speed of 5, turn speed of 180. So how fast can he turn, you know, in one update? The heart prefab, okay, and then regurgitated fish prefab. So we could turn our regurgitated fish into anything cool if we really wanted to. Okay. And then we have all of our private stuff here. Okay, so let's talk about what this is. So you have an agent. An agent is what gets the rewards or gets punished, right? So we have to, ML agents is kind of like an extra framework you add into Unity, right? To make it better. And so it's like it's adding like if you're in web dev, you know, and you're using Node, it's like npm install blah blah blah. You're adding another library into your main library to make it work. Okay, and so that's why we do a little override here, but it has its own specific things like initialize agent. Okay, which is going to be changed to initialize if you're looking at this in the future, and we're in 0.15. It's the name's changed to initialize. But we're going to initialize a new area, right? So we're going to get a new penguin area, which is a type. C# is a type-driven language, right? So if you know TypeScript and JavaScript or some other things, it just means that every time we declare some kind of variable, I believe, or function, we have to discuss the returns and the variables and all of the different data types whenever we manipulate data. So this is a penguin area. We create our baby, which is a penguin baby from the penguin area, and then we get our rigid body, which is a component rigid body on this agent. Okay, so what that means is the penguin agent has a rigid body here, right? And we only want it to move on the X and Y axis. We don't want it moving on the Y axis. So we don't want it necessarily sinking down into the depths of the water, right? Or going like this, right? We just want it X and Z. Anyway, let's go back into here. So the main things that we have is we got to initialize the agent. Then we have an agent action. So these are the things that the agent has to do. Okay? So it moves, it turns left and right, and it rotates. And this is a little hack, if you will, to work with agents. If you're doing this on any of your stuff, you give it a tiny negative reward on every step to encourage it to move faster to your target. So that's how to get things to move. You give it a little bit of a negative reward. So when we ran this, right, let's close this up and look at it. You notice it starts out, it starts going negative. See? Negative 0.02, and then it jumped up. And the reason it did that is because we give it a negative reward for just sitting there and doing nothing. Okay. Don't worry about this heuristic. This is just so this is for testing purposes, so we can move our agent around. Okay, agent reset. So this is whenever the agent is basically done. It dies or it goes to 0. We gotta restart it. These are the things that we set up. We reset the area, and we get the feed radius in case that's changed. Okay. So here's the last two areas that are very specific to agents. Collect observations. So what this means is that your agent has to remember the raycast that were sent out, and we picked up things like the wall. How far are we to the other soccer players? The goal, all that stuff, and those little red things that were shooting out. Those are raycasts, and it's just observations. They're like little pinging. We're pinging different things in the environment. Well, your agent has to be able to do that, and that's all under this collect observations. Now, they changed this a little bit in 0.15. One of the things that always has to be passed now is a vector sensor called sensor. And then these add vector observations are deprecated, and we're replacing all of them with sensor add an observation. So I'm not going to add this in here now. This code works for 0.14. But what we're doing is we're telling it essentially to look into the environment for different things. So guess what it's looking for? Whether the penguin has eaten a fish. Is it full? So if it's full, then it knows it needs to go back to the its baby and regurgitate. Distance to the baby. Direction to the baby. Direction the penguin is facing. Okay? And these are all controlled here in our ray perception sensor. Okay? And so we have these things called baby and fish, element 1 and 2. So we have baby. So that's how we're able to access baby here, right? And fish. That's how we're able to access all this stuff. So that's our ray perception. This is our ray caster, if you will. Now these two things, well, we'll get back to that. So that's, we collect the observations. And the last thing we do is the update. So this is every frame, essentially, we run this update to check for different things. So we ask the system to request a decision or request an action. So it's essentially saying, whatever happens, choose something to do at this frame. And then that's where it makes its decision. I think that can be refactored out later. We'll talk about that, possibly. Then lastly, we talk about a collision. So if the collision is a fish, right? So how do we know the fish? All right. So if we have our fish here, up here at the top, we have, see the tag here? We have a tag of fish. This fish has a tag of fish. Well, if we go up here, if it compares a tag of fish, so if the collision on the transform, or that object, if you will, if it has fish, then eat the fish. Try to eat it. Else, if it's the baby, don't eat the baby. Instead, regurgitate the fish. Okay? So that's what happens when it has a collision. And that's why you have your rigid bodies and your collapsibles on there. So it can detect those collisions. So it knows when it reaches an object. And then it calls eat fish. And then here we have, we eat the fish, right? So it gets a reward for finding the fish. Remember, that's one of our rewards. We reward it for finding a fish. Because then it can feed the baby. So the first thing is got to get a fish. So that's where we add the reward. 1F, one frame. Or I think it's actually just one float. I'm not sure about that. It's always 1F though. Okay? So we add the reward of 1. And here's what it's doing if it regurgitates the fish, which means it's full, and now it goes back to feed the baby. Well, it creates the regurgitated fish. It transforms itself. It destroys the regurgitated fish after it dumps it in front of there, spawns a heart, and it adds a reward. It gets a reward for here. And if there are no more fish remaining, it stops the simulation. Okay, I know that seems like a lot, but really it's not. Go through the tutorial. It is really not that much. But one of the things that you're going to see here is we're telling the agent how to respond to the environment. We're not telling it to do, specifically to, go out to this spot, run this search. If you find anything, go to this spot, and then do this and that. We're giving it goals, telling it to go towards those goals, and if it accomplishes those goals, it gets a reward. Right? Okay. Okay, so that was fairly heavy. I recommend going through this. I'll put the link in. So let's go through and actually, how do we train this? Okay, so right now I'm running a neural network on it. So if I go into here, let's go into our the penguin area. Agent. Right, we got our agent. So we have a behavior parameters, which is a component that you can add on here. And here's where the neural network model is. When you install ML agents, it installs TensorFlow. Okay, so you are using TensorFlow. Bummer, but that's what you got. No PyTorch right now. If we take this out, okay, so let's just highlight it and hit delete. See here it says there's no model for this brain, so it cannot run inference, but it can still train. Okay, that's what we want right now. So if we wanted to continue to train something, we drop in the current neural network and we let it continue to train. But right now we're going to train it from scratch. Okay, so what do? How do we do that? So we go in here and we go into our ML agents download, and we have ML agents learn. All right, so that's the binary that runs. We tell it to get this configuration, so trainer config.yaml, which is if you've ever done any kind of deep learning, you recognize all these. These are all your parameters. Learning rate, max steps, how much memory to use, number of epochs, summary. I mean, you know all these, or at least you should. Okay, these are the default settings. These are all the example. So if you had the 3D ball one, these are their specific parameters. So you can always set up your own individual ones if you just want to build on this. Just letting you know that, okay? And then, so we pass it in the parameters, and then we pass it in a curriculum, okay, which is this config curricula penguin YAML. And this is specific things it needs to know. So if we have a thresholds, any kind of parameters on the fish speed, these are all default settings if we don't put anything in. And what this means is that after you finish an epoch, it modifies itself. So notice here that in the first bunch here, the first 1, 2, 3, 4, 5, 6 levels, it goes through whatever it is, 7 or 8 levels. The fish speed is 0, so the fish don't move. But here at the end, after we figured that the system's gotten better, we add some extra movement to it to make it get better. And here's our feed radius. So this is the penguin, when it's running around, can see a specific group of fish, right? So it has a wide search radius. And then as it gets better, we narrow that down, so it has to be really, really good at locating a fish by the end. And so these are things that we change as the system trains and learns it, okay, as we go on. Okay, so let's go into here. And then we just pick a name for our, oops. I'm going to use Penguin 03, just so you can see what we got here. So this is going to come in here. So these are under ML agents. I have summaries. So these are all the different trainings I've run. We're going to do Penguin 03. And the reason I want to show you that is because I want to start a new one, all right, for TensorBoard. Now, if you don't know TensorBoard, right, TensorBoard is the TensorFlow way of checking to see what's going on in your training. So it's actually integrated in here, which is awesome. So here we got TensorBoard, and we're going to use the logging directory of summaries. Right, so we're going to see all those things that I've been working on in here, right? All these different folders, I'll be able to access all those different trainings in my TensorBoard. All right, so let's just start it up here. It opens up in localhost at 6006, okay? And then what I'm going to do is I'm going to start training this. And there we go. I'm a sucker for the ASCII art. I love it. That's when you know you got some serious coders right there, right? Okay, and then I'm just going to hit play in here. And boom, it's training. Now, look at how horrible it is. It's at 0.2, 0.29, 3.3, 3.5. It's going down. It's terrible. It can't find anything. And that's because that's where the system starts. And it's going through, and if we let's see here. Let's go into our penguin area. Let's go back to the actual scene. See our ray casting happening over here, right? So you can see it. It's looking for its distance to fish. Remember, it's ray casting. If we look in here on our collect observations, it's looking for distance to baby, direction to baby, is it full, and where it's facing. So we expect to see 3 to 4. And so you can see that as it's going through, putting out those rays. So the little red ones look like distance to fish. Actually, I can't tell which ones are which. But you can see all the ray casts happening, and it's hard, and we can see that it's absolutely horrible at doing this. Okay? Now, when we come in here, we can see that one of the nice things from the ML agents is that it keeps the time elapsed and tells you what the mean reward is and the standard as it goes through. Cool. Awesome. So we can keep track of that and see as it gets better. Now, if we go up to TensorBoard, let's look at TensorBoard, and let's look at Penguin 03. Bam! We have our training. So you can see the different cumulative rewards as it's going through here. I have the smoothing turned all the way up just because I'm a big fan of smoothing, but it's not for everybody. But in these particular instances, it works. We look at the policy loss, value loss, and again, we can check all the different value and reward estimates and learning rate. We can see pop coming down as we go through. And you can check out all these things as it's training. So if you're used to TensorBoard and doing traditional deep reinforcement learning using TensorFlow, you got all of your tools here. If you're used to Unity, you can look at it here and check out everything, and right here in the terminal. And so this will go on for a while until it reaches its, I think it's called a step. I forget the terminology exactly, but that's when, remember, once it reaches a step where it achieves a certain amount of threshold, whatever it is, it'll move on to the next setup here and try to make the system a little bit better. Okay, so that's that. So I'm just going to stop training for now so you can see what we got here. So as it's finished, what it does is it doesn't just quit. It wrote the model to this penguinlearning.nn file. So if I go into here, and I see here's Penguin 03 learning now. There is, that's supposed, let's see, models, let's see if that's the right one. Nope. Well, that's the training. Yeah, that's not what we want. That's the actual training. So let's look at the ML agents. Let's see if we can look. Ah, there it is. Models, Penguin 03. There's our Penguin Learning neural network model right there. Okay? And so that controls all the weights and everything. Here's your checkpoints. Frozen grass, if you're used to using TensorRT and TensorFlow and all those other things, boom, you got it all right there. Okay. So then what we do is we can go in here into Unity and we can find our models and we can dump in whatever we want. So here I can import a new asset, and I can specifically tell them which one I want. So if I want, mine is under, I think I have it under Applications, ML Agents, Models, Penguin 03. I could turn this Penguin Learning, I could bring it in here. Now I don't want to do that because I already have the old one here, which was fully trained. But that's how you would do it, right? So you grab this. Now if we go back into the Penguin, let's get back to our agent here. Sorry, I didn't lock it. There we go. So let's lock it so that this doesn't disappear. So we look here, and it's still, we need to find the neural network model. So there's still none. Well, let's go in here. Let's drop our Penguin Learning neural network model that we trained and dump it into the model. And boom. And then we'll come back in here, hit play, and our agent should be pretty good. Boom. Coming back. Drop it off, regurgitate, get your heart. Boom. Going out, seeing the other one, go straight for the fish. All right. So there you have it. So it's much better system at doing all that. Okay. So that covers the ML agents, TensorBoard, all the things that are going on. That was really, it's an hour. That's a lot, I know. I already talk fast as it is, so I appreciate you sticking with me. There is a lot of potential here. OpenAI Gym, right? The OpenAI Gym, which we looked at, which is very popular today. Look at these. Their environments are all flat, and they have physics simulations, but they're not very customizable. So think about all that you can accomplish with a full physics simulation that any 3D artist could design an environment for you. And that's one of the things that we're really excited about at Suji. If you're into C#, and you love this stuff, I'd love to talk to you more, because we're doing some really cool things that we feel are game-changing in this environment. Also, if you're in the VR and AR space, a lot of this might come in handy as well, training your agents there. So that's about it. Thank you, everybody, for coming out. I'll open it up to questions. If anybody has anything, let me know. So let's see what we got over here. All right, so Wes is asking about negative rewards, right? So we're punishing the agent. Often we're punishing them for sitting still, is what we're doing. And it just encourages that initial action. Otherwise, because sometimes if you reward a system for specific, like we've seen this before in deep reinforcement learning. Let me turn this off just so fans might stop a little bit. We've seen this in deep reinforcement learning where you train an agent for a high score, right? And then what does it do? Well, it'll sit on one little spot in the game and just constantly, to get the scoring, right? It just wants to score. It doesn't understand the idea of actually playing the game and going through that process. So often a negative score will encourage it, or negative reward will encourage it to continue moving past that environment and do a more searching, right? So that's the bandit problem that we talked about in Wes. I mean, I know you worked with Ashton a little bit on that, on the bandit problem and curiosity versus whatever the current reward is. I can't remember the exact terminology, but to encourage the system to more curiosity, right? Pushes it towards that, I think. Yeah, it receives it on each frame, Wes. Yep. All right, what else do we got here? Yes, Jerry. So it gets a reward function each time the fish is delivered, and also each time it eats the fish, right? So capturing the fish and then delivering the fish are two separate goals. Traditionally, you would set that up in a GOP. Goal action oriented program, or whatever it is, you would set that up as go to fish and go to person. And so instead, the goal is just a function that it gets rewarded for. So it learns how to go to fish and learns how to go to deliver that. So yeah, that's kind of how that works. Yeah, and then it decays over time because of the negative reward to obviously push it to continue to move. Yeah, cool. Hey, good to see you there, Leon. Thanks for coming out, man. Cool. Well, I definitely love this. If you guys have any talks you want to do next month for this, let me know. I'm totally open to whatever people want to stream, whatever they want to do. I mean, within reason, of course. Let me put a proviso on that. But yeah, I'd love to hear people's ideas about some new things that are coming out, or if you have ideas for stuff. Yeah, I think that's about it. Cool. I don't have any drinks for anybody. That's a bummer. I have tea. Here's to you guys. How's everybody else doing out there? Anything new and exciting? Let's take. I'm just gonna throw up a couple more of these so you can see some of these. Let's take a look at the tennis demo. Look at all those tennis courts. So this is a system learning competitive play. Learning the rules of a game like tennis. And then learning how to play. It's pretty cool. I like that one. It's a good one. Let's see, I haven't looked at all these yet, so let's see what else we have here. Food collector is an interesting one. So this is one where the environment's constantly changing. Actually, when I watched War Games the other day, this is what I was working on and sampling, and I felt really freaked out because essentially this is a world simulation that we're running, and we're running predictive behaviors, and this is exactly what the system from War Games was about, was running these kinds of simulations and determining outcomes. And if you listen to how they describe it in War Games, it says it essentially learns the rule of the games as it goes along. They built a deep reinforcement learning system back in 1983, according to the movie, of course, that, you know, carried the rules of war and engagement, which was pretty neat. But this was neat. I mean, you can see you can see all the raycasts going out of the environment and constantly being regenerated and going through and learning all kinds of new things. So I kind of started switching a lot of my work over to the Unity3D environment, some of the deep reinforcement learning that we're doing on our projects, because this stuff is it's just really top notch. I haven't seen too many robotic stuff in there, but they're starting to put it in, like the Kuko bots and stuff. Let's see what else we got here. Let's check out their walker. I haven't seen their walker yet. All right, let's see what this guy does. Or girl. Well, that's kind of freaky. It's like having a seizure as it walks. Alright. Well, I mean, it's working. I mean, this is why you gotta be careful about your reward function. Oh yeah, that's cool, Jerry. Yes, Wes. War Games, I love that movie. I watched it like 10 times already in the last 2 weeks. Oh, man. Oh, how'd you do this in middle school, Jerry? That's kind of crazy. You got a color food to collect to demonstrate... Oh, that's kind of neat. Yeah, sequence models. Oh, that reminds me, Leon. Thank you for the reminder. So, one of the things that you can do in here to make your agents better is you can create recurrent networks. And it's just one line of code. I mean, actually, there's a little bit more to it, but it's almost basically like a line of code. So I think it's here, use recurrent, right? False and true. And that will allow you to maintain like a system memory of sorts for the system as it goes through and learns these things. It makes it better, but it does make training slower. So a little bit of a bummer of that. Just a bunch of us in the gym. That sounds kind of fun, I guess. It reminds me of old dodgeball and stuff in the gym. Or street... did anybody play street hockey when they were in gym class? That was the best, when you'd break out the sticks and play street hockey for gym class. Man, that was a lot of fun. But you got to demonstrate population and food chain impacts. That's probably better for you overall, I think. Sequence models for NLP. Nice. Yeah. That's right. Coursera. That's cool. Yeah, I mean, I'd highly recommend if you're into any of this stuff, the deep reinforcement learning. Unity's got some great things. I got a couple of the books from Manning, and they've been pretty good. So, cool. Who else is on here? I know there's a couple of people on here. Nice. Okay, cool. Nice. All right. Well, I think that about wraps it up here, ladies and gentlemen. Thank you so much, everybody, for coming out. We're going to do this again next month. I'm going to put all these links. I'll make them available on our website, lancasterai.com. Again, if you want to work on any of this stuff and you think it's really awesome and you just want to kind of play around, I mean, it's kind of like a mini internship that we're running right now with it, but I'm working with some people to make some pretty awesome stuff here. And, as always, we're trying to make some cool stuff. That's all we like doing. I think everybody here just likes making cool stuff. And so we'd love to hear from you. Reach out to us on the forums, Lancaster Tech. It's on our Slack channel. I forget what it is, AmishTechSlack.com. If you email me at info@lancasterai.com, I can see if we can get you on there or get you into a separate Lancaster AI channel, and we'll get you connected there. So thanks, everybody, and I'll catch up with you soon.